fundamental theorem of calculus. The fundamental theorem of calculus. That looks a little messy. And so a lot of people, this will become FTOC. And so a lot of people will write that instead of fundamental theorem of calculus because it's a lot easier. But so before I actually tell you what the fundamental theorem of calculus is, let's do an example and kind of pick up from where we left off in the last section. So here I'm gonna let f of t equal the line 2t plus 2. And then in part A, what we're gonna do is we're gonna do what we were doing last time. So compute the integral from 0 to 2 of f of t with respect to t using geometry. And so I'm gonna draw out the graph. So here's my axes. And then actually let me make these bigger so you can see them. Oops. So there's my axes and then my line. So 2t plus 2, that's going to have a y-intercept of 2 and then a slope of 2 as well. So it's going to go up 2 over 1. So this is going to be the point 2 comma 0 and then up 2 over 1. Does not go there, it goes here. And so this is the point 1 comma 4. I just realized this is 0 comma 2. So yeah, this would be 4, this would be 1. And then so 2 is going to be up here at 6. Did I do that right? When you plug in 2, do you get 6? Yeah. So this is my line from 0 to 2. And so the shape that I'm getting now, I want to find the area of this shape, essentially. Do you guys know what shape that is? Yeah, it's a trapezoid. And so here is, if we have a trapezoid like this, then the area of this, so if this is A and then this is B, the area of a trapezoid is going to be 1/2 times that height times A plus B. And so if I go over here, this is going to be B, this is going to be A. And so I'm kind of, it's a rotated trapezoid essentially, and then I'm going to have this be my height. So here, this is going to be H. So when I do this integral, so when I do the integral from, whoa, that, okay. But yeah, so when I do this integral from 0 to 2 of f of t dt, I'm going to use this formula for the area. And so I'm going to have 1/2 times its height, which is going to be 2, times A, which is 2, plus B, which is 6. Oops. Is everybody okay with that so far? And so when I do this, the 2 and the 1/2 cancel, and so you're just left with 8. So the answer here is 8. Let's do that one more time just so you kind of, like, just in case you're still a little confused. Instead of doing from 0 to 2, let's see what happens if I change it from 0 to 4. And so here, we're going to have almost the exact same thing, right? Except I'm going to go from, I'll go, so here's, let's say, I need this to be kind of, I need this to be taller actually. because I have the point 10 comma 4, and so I'm going to need my y-axis to be pretty tall. And my x-axis doesn't need to be that long. Oh no, what just happened? Okay, here we go. All right, so here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the point 4. And so this is what your trapezoid is going to look like. It's still going to have the point 2 comma 0. So now it looks like this. And so this time, oh geez, I can't do a straight line, and I feel like these are not thick enough. But yeah, so this time you're trying to find this area. And so the only thing that changes is the height and B, right? Because here, so this is going to be A, it's still going to equal 2. This time B is equal to 10, and then this time H is equal to 4, right? And so when you solve this integral from 0 to 4 of f of t dt, you're going to get 1/2 times that height times A plus B. And so here you're going to get 24. So is everybody okay with these two parts, parts A and B? Because what I'm going to do, the next part is going to be go from 0 to x, not a specific number, but any real number x, right? So if you have any questions about either A or B, you should ask now. Okay. So then part C is going to be compute the integral from 0 to any real number x, right, of f of t dt. And so what we're going to have is our graph is going to look like this. You know what? I'll keep that thickness. And then, so here's 2 comma 0. And then what I'm going to do is it's just going to go up to f or x comma f of x. Right, so where this is going to be the point 0, this point on the x-axis is just x. So on the y-axis, what can I label that as? This value right here. Yeah, it's going to be f of x. And so here I have the point 2 comma 0 still, but now I have the point x comma f of x. And so if you look, if you try and compare everything, my height is just going to equal x, right? Because it's the distance from 0 to x. A is still going to equal 2 because I'm still going up to 2 comma 0, right? But then what is B equal to now? Yeah, it's still f of x, right? Because that's the height for this side. So the height of this side is going to be B, and the height of that side is whatever we get when we plug x in, right? So B is f of x. And so when you find this integral from 0 to x of f of t dt, you're going to get 1/2 times the height, which is x, times A plus B, which is 2 plus f of x. Here, what I can do is I actually know what f of x is equal to. It's equal to 2x plus 2. So I can simplify this a little bit, and you can have 1/2 x times 2x plus 4. And so when you finish simplifying this, you should get x squared plus 2x. And so if you've seen integration before, then or if you, well, okay, that was bad. We've all kind of seen it before now. But if you remember back to when we were doing antiderivatives, if I had told you, so I gave you that f of t is equal to 2t plus 2. So if I were to ask you to find the antiderivative of this, you would have given me that with t's though, and then maybe like a plus c, right? And so what we're now seeing is that antiderivatives and integrals are essentially the same thing, right? But so are there any questions about either parts A, B, or C? So parts A and B were with specific numbers, and then C was a generalization of A and B, right? So with whatever number that you put in there. So if I were to let x equal 4, so if I let x equal 4, then I should get 24 by plugging this in here. And so you get 4 squared plus 2 times 4, which is 16 plus 8, which does give you the 24 that we found above. So this now works for any value of x that we want it to. So are there any questions about that? I'm going to erase all of this. Okay. So then now part D of this example. In part D, we are going to define the area, well, the area function. And so it's going to be capital B of x. And so that's going to equal the integral from 0 to x of f of t dt. And this gives, so this is what gives, which gives the area under f of t between 0 and x. What is, and so we're going to have like little mini problems in here. Capital B of 2. So I was just kind of talking about this, but when you plug 2 in to this right here, this integral, so instead of having from 0 to x, you're not going to have from 0 to 2 of f of t dt. What should I get? There's 2 different ways that you can try and answer this question. You can either go back up and look at part A, or you can use part C, right? Yeah, it's going to be 8. And so this is 8. So this is from part A, but you'll get the same thing when you just plug 2 into part C. And so let's do that. So the second part here, let's find the area from 0 to 6 without drawing out the picture now, right? So when we do from 0 to 6, this is going to be the integral from 0 to 6 of f of t dt. But that was equal to x squared plus 2x, so you're just going to get 6 squared plus 2 times 6. And here you're going to get, what is this, 36 plus 12? What's that? 48. And so that's going to be the area under the line 2t plus 2 from 0 to 6. Whoa, it just started raining really hard. Okay, anyway, any questions about I or 2I? Okay. So then let's do one more of these. So if I were to do 0, what do you guys think I'm going to get? Yeah, it's just going to be 0, right? Because this is going to be the integral from 0 to 0. And one of the properties that I had given you last time was that anytime you have an integral from a to a, you're going to get 0, right? So just kind of keep those things in mind. So let's go to part E. Part E here asks us to find the derivative of B, of capital B. What is the derivative of this going to be? So here, what it's going to look like is I'm taking the derivative of the integral from 0 to x of f of t dt. So what can I do? What happens with these two things right here? Yeah, they're going to cancel out. So that's one way you can think of it, is that you're going to cancel out, and so you're just going to have f of t. Another way you can think about it is we found this earlier. This is b of x, right? We actually found that that was x squared plus 2x. And so I can just replace that now. So I can have x squared plus 2x. But when you take the derivative of that, you're getting that 2x plus 2, which is what you would get if you just kind of canceled those out, right? So there's a few different ways of thinking about this. But do you have any questions? I think it might be hailing, actually. Okay, anyway. So the next thing we're going to talk about is the first part of the fundamental theorem of calculus. There's actually two parts. The second part is the more fundamental part. But so here, so yeah, we're done with this example. So if you have any questions about that, make sure to ask. But so let's talk about the fundamental theorem of calculus part 1, and I don't want to write all that out. So I'm going to be lazy, and I'm going to do FTOC part 1. All right, so the first part of the fundamental theorem of calculus says that if you have, so if f of t is continuous on the closed interval from a to b, then the function g of x, which we're going to let equal, and so let me put a little bit more space on here. So g of x is going to equal the integral from a to x of f of t dt. So if this one, if f of t is continuous, then that means g of x is also continuous on that same interval. And it's also differentiable on the open interval from a to b. And the derivative of g prime, or the derivative of g, is going to equal f of x. And so here I left out a little note. I should have included, so here, like if I star this, x is between a and b. Another way of writing this out, oh my god, it's getting loud. Can you guys hear the rain? No, huh? Oh no, because it would say talking if you could. But anyway, So another way of writing, so other notation is if you take the derivative, so kind of that notation that I have up above, and then the integral from 0 to x of f of t dt, or from not even from 0, but from any a value, this is going to equal f of x. Actually, you know what? I think it is specific to having 0 there. All right, so let's do some examples with this. Oh, okay, wait, hang on. There's another note down here that I should include. So let's write this out real quick. Basically, what I'm about to write down is that the area under your curve, so like the bigger you let x get, then your area is going to be getting bigger and bigger, but it's going to stay almost the same as the height of your curve at that x value, if that makes sense. And so we kind of saw that up here, right? In these first two examples, A and B. As my x value gets bigger here, my area is getting bigger, but it's staying like in relation to the height at the x value at the endpoint, if that makes sense. And so let's write that down in words. All right, so the rate that the area is accumulating at, or accumulating under the curve, at a certain x value. Okay, that was weird. Is the same as the height of the curve at that x value. Is the same as the height of the curve at that x value. So, oh, you know what? I just realized this first example. So right here where I had 0, you can put any letter A here, or any number A. I mean, it doesn't have to just be 0. But so for this example, we're going to differentiate. So in part A, I'm going to let g of x equal the integral from 3 to x of cosine of e to the t times t squared dt. So here, if I kind of go back, oh shoot, sorry, hang on, I just unplugged this. It was an accident. Should come back right now. There it goes. But if I kind of go back up and I compare this to the other notation that I had written down here, what would my f of t be in this example? It would be that cosine of e to the t times t squared. Yeah, so it's going to be all of this. So don't forget that piece. And so here, cosine, not co, cosine of e to the t times t squared. And so if you look at, oops, I don't know what I just did. If you look at this right here, what this is saying is that you basically just take f of t, and then when you take the derivative of the integral of that, you're just getting f of x. And so here, f of x would just equal, what is it, cosine of e to the x times x squared. So that means g prime of x is equal to f of x, which is equal to cosine of e to the x, x squared. Any questions about this first part? All right, so let's do another one like this. So if I look at part B, then I'm gonna let h of x equal the integral from x to 5, right? So those limits are switched. That's not how I want them. Of secant of t cubed over ln of t plus 1. Oh no, I just got the internet connection unstable sign. Is it okay for you guys? It's not lagging or anything? Also, am I writing big enough? I feel like this is kind of small. It jumps. Okay. Secant. What did I have? Secant of t cubed. Huh. Okay. Yeah, we'll see how this goes. I have been looking into switching to something other than Zoom for various reasons. So we'll see if I can find something else. But Zoom is like the most user friendly, but it's also the most creepy. So yeah, I will keep you guys updated on that. But if it starts causing you a lot of problems, like if you can't keep up with the lecture, then let me know. I don't know how to use Twitch though. I feel like that's only for gamers. But I know a lot of people are doing it. I might look into that. I was thinking Discord, but I don't think you can have video on there. I think it's only chat. But I'll have to look into it. I've just been really busy. You can't even tell what that says. Oh, you can? Okay, then I might switch over to Discord. I don't know what OBS is, but if it's hard to set up, I'll probably not set it up. But anyway, okay, so if we go back to this example, we want to find h prime of x. And so I'm not going to do all of the steps here, but basically this is going to be my f of t, right? And so when I do h prime of x, I'm basically just going to replace all the t's here with x's. So I'm going to have secant of x cubed over ln of x plus 1. And so that's the derivative, right? Oh, no, it's not. I missed one thing. All you have to do before you find that is you want x to be your top limit. And so you're just going to switch this. And remember, when you switch your limits, you just make your integral negative. So all that changes to my answer is it makes it negative. So any questions about this one? Make sure you include that negative right there. All right, so let's do part C. Oh, somebody left. Oh, probably it may have been laggy. I don't know why. It's only your class too that has issues. All three of my other classes, they're perfectly fine, and they say it's never any lag. So I don't know what's going on with yours. Maybe I'll look into that. But okay, so here for part C, we're going to look at the function k of x. And so I'm going to have that is equal to the integral from 0 to x squared. So not x this time, but x squared of the square root of 1 plus t cubed dt. So here, notice that I now have x squared instead of x. And so all that really changes is wherever you would have just had an x before, you're now going to put an x squared. And so here, the derivative of k is equal to the square root of 1 plus, normally I'd put an x right here instead of a t, but I'm just going to put an x squared this time because that's what I care about. So are there any questions about that? So this becomes the square root of 1 plus x to the 6th. Oh, but then, so I'm missing something. Sorry, forgot to include this. But because this is a derivative, you have to take the derivative of this guy now, right? It's very similar to the chain rule, kind of. And so you have to take the derivative of your inside, and so my inside here is going to be x squared, so you have to multiply it by 2x. And so here you're getting the square root of 1 or 2x times the square root of 1 plus x to the 6th. So any questions about that one? Okay. So let's do one more like this. Part D, my Apple Pencil may not make it that long actually. So let's see. Part D, we're gonna have little m of x. This is gonna equal the integral from 2x plus 1 to 5x cubed of sine of t squared dt. Here we need to be super careful because if you look back up here, right, we only really have one expression with x in it. And so when I scroll back down here, I kind of need to fix this a little bit, right? And so what I'm going to do is I'm going to split this up into two separate integrals using some of those rules that I gave you last time. And so I'm going to say, rather than having it as one integral, I'm going to say that little m is equal to the integral from 2x plus 1 to 0 of sine of t squared dt plus the integral from 0 to 5x cubed of sine t squared dt. Right, so remember that those two things are, these like two lines are equivalent now, right? And usually when you want to split it up like this, you're usually going to use 0 as your like middle point because it's always easier to do it with 0 right there. And so before I finish any of this, I need to flip these limits again. But when I flip those limits, I make the integral negative. So I can make this 0 to 2x plus 1 of sine of dt, or sine of t squared dt, plus that same integral that I have above. Any questions up to this point? Okay, so then here, what I'm gonna do is I'm gonna say, okay, f of t is essentially this sine of t squared. So f of x would be if I plug that in, but since I'm taking a derivative, I'm also gonna need to take the derivative of this guy and then multiply it, right? And so here you're gonna have sine of 2x plus 1 squared times 2, because that's the derivative of 2x plus 1. Oh, it's negative. I forgot that negative right there. So negative sine of 2x plus 1 squared times 2. Then I'm going to do the same thing with this second one. Instead, I'm going to have sine of 5x cubed squared times the derivative of 5x cubed, which is 15x squared. And so if you simplify this a little bit, you're just going to get negative 2 sine of 2x plus 1 quantity squared plus 15x squared times the sine of 25x to the 6th. And so there would be your answer. So are there any questions about any of these examples that I've done today? Okay. Real quick, let me do one more example. Well, technically two more, but they're both really quick. So here, my first one, if I take the derivative, and after doing all of these, it's going to seem a little easy, but if I take the derivative of the integral from 3 to x of cosine of t dt, what am I going to get when I try and take that derivative? No, you don't need to FOIL. Like this, you could just leave it like that if you wanted to. Yeah. But yeah, so here when I do this derivative for part A, what am I going to get? Right, so if this is f of t, so cosine of t, and then the derivative of this is just f of x, then what am I going to have here? Like what am I going to have? Cosine of what? Yeah, just x. So that's part A, but then, so if I compare that to part B, what happens if I change x to 5? Then what is my derivative now? Yeah, it's just going to be 0. And so here, this is what we did an example exactly like this last time. And so this is just kind of getting you thinking about when you have x here, it's going to be a function, but when you have numbers here, it's a definite integral. Well, they're both definite integrals. But when you have variables and your limits, you get a function. When you have real numbers in your limits, you get a real number out, right? So remember that definite integrals are just numbers. And so technically what you're doing here is you're differentiating a constant, which will give you 0. So are there any questions about anything that I've talked about today? I'm going to stop it here for today, and then we'll talk about the next part of the fundamental theorem on Monday, because you guys know Friday's class is optional, right? Because you guys have an exam. And so really you only need to come to class if you have questions about the exam.